Our project is design and analysis on inspection door in a typical coal handling plant gravimetric feeder. Myself Dinesh Raj, my teammates are A. Bhunesh Kumar and Sebastian Prabhakar. Our project is internally guided by Mr. S. K. Nagarf Ali, who is working as an assistant professor in Beltec Engineering College, and externally guided by Mr. V. Anbarasan, who is working as a senior engineer in PHEL, Ranipet. This is our industrial profile, may also available in their official website with detailed description. Abstract. Our project is design and analysis on inspection door and extended casted in gravimetric feeder assembly. Aims to design and propose an advanced inspection door of thermal power plant coal handling equipment gravimetric feeder. Our design includes a new design in front and rear inspection doors and removal of casted portion which is placed in between side inspection doors and supporting rollers. Also, an extended portion is designed for the replacement of casted part can free from welded portion. By implementing this replacement of front and rear inspection doors and replacement of casted portions in shop floor can overcome the following problems faced during the manufacturing. Problems are excess of manufacturing and weight, manufacturing time, cost and reduction of casting and welding defects in that particular casted portion. Also can prevent from pressure leakage defects in thermal power plant. These are the such keywords we have used. Introduction. Coal is an abundant available natural resource used as input fuel in thermal power plant for generating power. Thermal power plants burn the coal in the boiler to generate thermal energy which is turned in used to convert water into steam. As amount of coal equipment as amount of coal required for the typical plant in use, both in terms of volume and weight, there is a need for huge infrastructure to support it in mains. The raw coal from the yard is transported to the pulverizer where it is crushed and rotated into the boiler through the need to measure the coal before it enters the pulverizer. The most effective means of controlling the input is by measuring coal mass through feeders. Though this is the total coal weight feed into the boiler can be computed. The feeder must deliver the coal mass at the rate proportional to the demand. This must be done independently of coal physical parameters. The coal feeding efficiency of GFC is calculated by taking percentage error between coal assumed as per consumptions. This is how we have identified our project. In PHL, we have started our various production bay. Uh, First of all, A1, A2, A3, and then we have forwarded to move on to F1, F2, F3. At last, we have reached the FH1B. We have studied a lot of problems in process and productions. Okay. Hence, we identified our project to change the front and rear inspection doors of feeder body, also removal of roller casted portion. By this, we can overcome the following problems faced during manufacturing. Problems are excess of manufacturing and weight, manufacturing time and cost, and reduction of casting, welding defects in that particular casted portion. Also can prevent from the pressure leakage defect in coal handling plant. This is how the gravimetric feeder. This is a schematic. This is the schematic sketch of the gravimetric feeder. Gravimetric feeder is nothing but a belt conveyor which measures the amount of coal in terms of weight being conveyed to the pulverizer. The feed rate is computed from a load cell signal and belt speed signal collected to the load cell strategically mounted before the belt, and the hollow shaft sensor mounted on the tail pulley of the belt conveyor in the way controller. In the way controller. This is an existing design of gravimetric feeder, and this portion is inspection door and this is a portion of casted region. This particular region consists of around 40 kgs of weight. Design of gravimetric feeder. The proposal is designed as required structure with proper dimensions. Also analysis answers with respect to pressure, temperature and weight. This material thickness is reduced from 12 mm to 10 mm. The locking system of casted up is replaced with M24 bolt of 4 numbers in the grade of SA105. This is our new design for the inspection doors, and this is a side view of inspection door. This region is called the casted portion, which is used for the supporting area. At last, analysis of gravimetric feeder. The inspection door has been analyzed in three various thickness. For example, 12 mm, 10 mm and 8 mm. The door of 10 mm thickness has been satisfied for applying all constraints. On account of it, analysis report of shear stress, shear elastic strain and shear deformation, total deformation has been explained in detailed report. Methodology. First of all, we have seen the gravimetric feeder. At last, we have started studying about the gravimetric feeder. While studying, we have noted that the inspection door and the thickness may also be able to reduce. At last, we have analyzed and we have designed an analysis with a Inspection door with 10 mm thickness is safe to withstand the required temperature and pressure. Design of 10 mm thickness has at last final. Proposed system is designed in required structure with proper dimension, also analyzed in with respect to pressure, temperature and weight. The system need to withstand at least of 2 psi pressure, and we have given for around 4 psi pressure for its extension. This design includes a new design in front and rear inspection door and removal of casted portion, which is placed in between side inspection door and supporting roller. Also, an extended portion is designed for the replacement of casted part can free from welding operation. By implementing this replacement of front and rear inspection door and replacement of casted portion in shop floor can overcome the following problems faced during manufacturing. Problems are excess of manufacturing and weight, manufacturing type and cost reduction of casting, and welding defects in that particular casted portion. Also can prevent from pressure leakage defects. This is the 3D model of our proposal design, which is done by CATIA software. Comparison. At last, comparison. We have compared with the existing system as well as proposed system. In inspection door, we have eliminated the bend, which takes around 2 days, and we have eliminated the thickness of the material to reduce the material manufacturing time, material defects. At last, locking. Inspection door is locking with a large huge up, which is weighted of around 40 kgs each. So we want to search a new design where the system is hinged with the bolts and elimination of locking ups. At last, elimination of casted portion. This casted portion is used to hold and sensor, and the diameter and the internal diameter, which will be same as the roller diameter, but they are using a special casted portion to hold that up. It is not required. That's why we have eliminated this casted portion and extended this roller portion at last to hold the sensor. Advantages. This proposed design of inspection door will help to reduce manufacturing cost, manufacturing materials and manufacturing time, also used to increase in efficiency. Removal of caster up in the inspection door will help to reduce weight and make the locking easy. Proposed design is elimination of caster portion on weighing sensor will help to reduce production cost, manufacturing cost, also help to reduce in pressure leakage. This is the application side. The primary application of gravimetric coal feeder is for feeding coal to boiler. However, it is used for any solid fuel feeding to boilers. These are the some of the reference where we have taken. Okay, at last. Thank you.